All right, so we've looked at solving two-step equations, so we're just going to add a layer to that and look at situations where we have equations where we have to do some simplifying first. Okay, so just as an example, let's say we had something like 2n plus 4 minus 6n plus 6 is equal to 2. Okay, so we've got 4 terms on the left side, and we want to be able to get that down to 2 terms so we can go through our steps for two-step equations. Okay, we're not going to start solving this yet. You could, but typically we want to combine as much stuff together, simplify first before we start solving. So really we just need to identify what are the like terms here in our equation. What can I combine together? So I take a look, I've got a 2n, and I combine that with a minus 6 again. Again, be careful of the minus. Okay, we've got to pick that up. We've got to recognize that as being a negative. Okay, we can't go 2n and 6n make 8n. We've got to recognize that that is a minus there. Okay, and then we've got our constants there of plus 4 and plus 6. Okay, so we only want to combine on the same side. I can't go and combine the 2 with the 4 and the 6. They're on other sides of the equal sign. Just like if I had 2 plus 2 equals 4, I couldn't combine the 4 and the 2 together and make 6 somehow. That wouldn't make any sense. So same thing here. We can only combine things on the same side of the equal sign. Okay, so in this particular case, 2n minus 6n would be negative 4n. 4 plus 6 is 10. So that would be my two-step equation. Then we go through our steps, undo our addition or subtraction. That zeroes out. Rewrite our equation. And then divide by, in this case, negative 4 to get n is equal to positive 2. Okay, so combine your like terms first before we start to do our two-step equation method. Another example of one you might see is something with parentheses. So you might have something like negative 4 parentheses 2n plus 5 equals let's say 12. Okay. All right. So we'll go over 2 techniques you can do here. One works in all situations a little bit better than the other one, but the other one, if you can kind of recognize a thing here, it'll make sense as we go through this. But so one way I could do this is to first get rid of parentheses. Use that distributive property that we learned about. So negative 4 times 2n. Okay, negative 8n, negative 4 times 5, negative 20. Okay, so we could get rid of parentheses, then we could go through and do our two-step equation, right? So I'd add 20, add 20, undo the minus 20 or zero out the minus 20 to get 32. Okay, then negative 8n equals 32, so we're rewriting our equation, and then divide both sides by negative 8 to get negative 4. All right, so that's one technique. Now, a second way we could approach that is if we notice, I get my highlighter here, that this number, okay, negative 4, and I have 12, those go in, 4 goes into 12 evenly, right? So we can use that to our advantage on this. So one thing I could do before I start, or to get it down to its two-step equation, is I could divide both sides. Oops, let me undo that here. I could divide both sides by negative 4. So by doing that, what happens is those cancel out, and then I'm left with 2n plus 5 equals negative 3. And then I could go through my two-step equation like so. So subtract 5 from both sides to zero that out, and then divide both sides by 2. 2n divided by 2 is 1n. Negative 8 divided by 2 is negative 4. Right? And we see we get the same result. So in certain cases that'll work. To me, that's a little bit faster because you don't have to get rid of parentheses and then go through a two-step equation. It makes the numbers a little bit smaller. Where that's not going to work, or where you might want to do something different, like let's say add 4, n plus 3 equals 15. Right? If I divide both sides by 4, right? Then I get n plus 3. Well, 15 over 4 is a decimal, and typically we just want to leave it as fractions. So now you're dealing with fractions. So sometimes it's better to get rid of the parentheses. So like in this case, we could do 4n plus 12 equals 15, and then start working with it there. So it really depends on the numbers. You can work both ways, but if you look at that number and look at that number, and that's not, the first one's not a factor of that, I would recommend you first get rid of the parentheses. If it is a factor, like in our previous example, let me go back to that, right, where you got 4 and 12, okay, then that's fine. That's probably even a little bit quicker. Like I said, the numbers stay smaller, but either way is going to work in this particular case. It's just kind of a second option that you have. Okay. So to recap, right, make sure we combine like terms. Okay, and make sure we only do that on the same side of the equal sign. Right? Don't combine things on the left side of the equal sign with things on the right side. Okay, and then you got to deal with parentheses. Okay, and remember, we have those two methods. One method, use your distributive property, right, where we get rid of the parentheses before we start to solve it. Or in certain cases, if the numbers work out nicely, we can simply divide to get rid of that number in front of parentheses, and then work from there. So it kind of depends again on how well the numbers work together, but either technique's going to work. It's just a matter if you want to try and avoid fractions if you can, or decimals until the very end, if possible with that. So again, looking at two-step equations, just where we have to do some simplifying before we attempt to solve.